Okay, in chapter 6, section 4, we're pretty much doing the same thing we were doing before by simplifying expressions with rational exponents. So this slide just states that if we have, let's say, a number or an x, whatever it is, raised to a fraction, the number on top can either go on top on the inside or on top on the outside, and the number on the bottom is always going to be the index for the square root. So if we have, let's just say we have x, and this was raised to 3/2. So 3/2. The 2 would go out front here, which remember, if it's a 2, we don't need to put anything, but I'm just going to keep the 2 there to show you guys. And the 3 would go on top there. Or it could also be written as the 2 on the index, and the 3 can go as an exponent to the x. So these are the two options that this can be simplified to. Now I have some examples. So in the first one, we can simplify this. So since there's a 2 on the bottom, it's just saying the square root of 7 times the square root of 7. Now remember, if we have a square root times a square root, we can combine those, and their indexes are the same. So if that's a 2 and that's a 2, they have the same index, so we can combine them together. So we're putting them all under the same square root, so we have 7 times 7 on the inside. Now here, since our index is that implied 2, that means we're going to circle two numbers, and this 7 comes outside. So our final answer here is just 7. The next one, we have the 4th root of 5 times the 4th root of 125. Since our indexes here are the same, we can combine these and put them all under the same square root. So we have 5 times 125, all under the same square root. Now we could multiply this and then just factor it back out, but we already have two factors, so we can just leave it unmultiplied. So we have the 4th root of 5 times 125 breaks down into 5 times 25. And then we have the 4th root of 5 times 25 breaks down into 5 and 5. So since our 4 is our index, that means we're going to circle 4 things. So we have to circle all 4 of the 5s. So now what comes out is just a 5. So this simplifies to 5. All right, example 3 may not look like we can do anything here, but this square root of 7x cubed, the cubed means that we have this 7x 3 times. So if I erase this cubed, I'm going to erase the parentheses too. It's like saying 7x times 7x times 7x. So we have the same thing 3 times. So this exponent here just means that we're multiplying it 3 times. So we have the square root of 7 times 7 times 7 and x times x times x. So I just separated all these because 7x is just like saying 7 times x, 7 times x. So I reordered it so we have the numbers first and the exponent second. And now remember, if we have no number out here, it means that there's a 2 out there. So we're just going to circle our pairs. So we have a pair here and a pair here. We're going to take out whatever we circle. So we're taking out a 7 and we're taking out an x. And we leave whatever is not circled on the inside. So we have a 7 that's not circled and an x that's not circled. So that stays on the inside. So this here is our final answer. for this one, if you notice, it looks just like the last one, but the 3 is on the outside of the parentheses, where in the one before, the parentheses were inside the square root. So here, let's see if we get the same answer as the one before. So the 3 on the outside means that we have the square root of 7x times the square root of 7x times the square root of 7x. If all of these have the same index, then we can combine them and put them all under the same one. So we have 7x times 7x times 7x. Look familiar? So now we can just put all the numbers together. So we have 7 times 7 times 7 and x times x times x. And we can circle our pairs. So a 7 comes out on the outside and an x comes out on the outside, and we're left with whatever's not circled on the inside. So we have 7 times x on the inside. So we end up getting the same answer as the one before. So there's 2 different ways we can approach example 5. So I'm going to do one way, and then I'm going to show you how to do the other way, and you can pick whichever way you like to do it better. So I'm just rewriting it so I can show you the 2 different ways we can do this. So one way we can do it is we know that the 3 is going to be our exponent, so it can stay on top. And the 2 is our index. So the 2 would be right in front of our square root. So this would be the square root of 64 n to the 4, and the 3 just stays on top. So just like we did for the last one, this exponent means that we can write what's inside 3 times. So since this number is 3, we can just write it. We're multiplying it by itself 3 times. So we have square root of 64 n to the 4 times square root of 64 n to the 4 times square root of 64 n to the 4. And since all of these have the same index out front, which is that 2, we can write it all under the same square root. So we have 64 times n to the 4 times 64 times n to the 4 times 64 n to the 4. Well, I should have picked smaller numbers for this. So we have 64 times 64 times 64 times n to the 4 times n to the 4 times n to the 4. So we can break the 64s down into 8 times 8. So 8 times 8 times 8 times 8 times 8 times 8. Yep. And then here we're going to have a total of 12 n's. So we have n times n. Twelve times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 times. So now, since we don't have a number out front, that means that our index is 2, so we're circling pairs of 2. So we have a pair here, pair here, pair, 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 pair. And we're going to take out an 8, an 8, and an 8. So we take out 1 8 for every pair. And then we take out 1 n for every pair that we circled. So we have 1, 2, 3, 4, 5, 6 circles. So we have 6 n's that we're going to take out. So it's going to be n to the 6. And then we can just multiply 8 times 8 times 8, which will be 8 times 8 is 64. So 64 times 8, which is 512, and then we can't forget about this n to the 6. So that's one way to do it. It's a lot of writing if you have big numbers. Another way we can solve this is we can split it up into 2. So we are applying this exponent to the 64, and we're applying it to the n to the 4. So we have 64 to the 3 halves, and then we have n to the 3 halves. Oops, it's n to the 4 to the 3 halves. So we can write this 64 the same way that we did in the last one, where we have the square root of 64 raised to the 3rd power. So remember, if this is a 2, we don't have to write it. So the 2 goes out, and it's our index of the square root, and the 3 just stays on top. So the square root of 64, we should know, is 8, but if we want to do the math, 64 breaks down into 8 times 8, and we can circle these, and 8 comes out. So we have 8 cubed, which is like saying 8 times 8 times 8, which we just did on the last part of this, and we know it's 512. For the next part, if we have a variable that's raised to an exponent to another exponent, we can just multiply these two numbers together. So we have n to the 4 times 3 over 2. Now remember, when you're multiplying a whole number and a fraction, this would just be like saying 4 over 1, and we just multiply the tops and we multiply the bottoms. So we're just multiplying straight across. So we have 12 over 2 now, and 12 over 2 simplifies to, this is like saying 12 divided by 2, so 6. So this simplifies to n to the 6th power. So we just combine the number we got and the variable we got, so we have 512 n to the 6. So just to do this on the side here, I'm just going to do like a random example. So if we have x 6 times, let's say 5 over 2. So this would be like saying if we had x to the 6 raised to the 5 over 2 power. So we can just multiply these two numbers together. So it's like saying x, and then we have raised to the 6 times 5 over 2. So all we're doing is multiplying the tops together and then just leaving what's on the bottom. So we multiply the bottoms together. So 5 times 6 is 30. And then this is like saying 6 over 1. So we have 1 times 2, which is 2. So it'd be like 30 over 2. So this would simplify to 15. So this becomes x to the 15. So if we had this problem, this would be our answer. So this is just like a side note. You can ignore it, but it's just some extra practice if you guys wanted to help. So as you can see, this way is a lot shorter, but you can do whatever you're comfortable with. If you like to write it all out like we did here, then write it all out. Okay, for this one, so it's another example of what I just did on the last one. So we have n raised to the 8th power raised to the 1/2. So this would be just like saying n to the 8 times 1 over 2. So if we multiply 8 times 1/2, we would get 4. So we get 8 on top and 2 on the bottom, which 8 divided by 2 becomes 4. So our final answer would be n to the 4th power. If we wanted to, we could do this another way. So I'm just writing it here, like how we did on the last one. So we have 8 to the 1/2. The 1/2 just becomes our square root, so we have n to the 8. So this would be like saying n times n. 8 times, it's 4, 5, 6, 7, 8. And then we can just circle our pairs. And we have 4 pairs, so we have n to the 4. So either way you like to do this, whatever works best for you, but I find it easier just to multiply the two exponents. All right, so this is 6.4. Don't forget you guys have some homework problems to do for 6.4 that's due on Wednesday morning. Good luck on the homework and let me know if you guys have any questions. Just feel free to email me.